Hello guys, welcome to the Radco Academy, and this is chemistry paper 2 or rather science paper 2 from 2025 GCE. So if you're watching from for the first time, please guys help me subscribe and share this video, and also remember to like and subscribe. Yeah, so let's get into this. So this is section B on question 4. So this is about the more concept, and I believe that each one of us that is watching have got some ideas about the more concept. Okay, so without wasting much time, we can start now. So it says 4.00 grams of impure iron 3 oxide reacted with 600 cubic centimeters of 0.100 mole per decimeter cubic. So this is the concentration sulfuric acid. Construct the balanced chemical equation for the reaction. State symbols are not required. Okay, so you have been told that the state symbols are not required, so we can now go. Now the most important thing is to understand that when you're looking at iron, okay, when you're looking at iron, it is just Fe, okay, Fe, and then we know that this is oxide, so it's coming from oxygen, okay? It's coming from oxygen. So when you react the two, it's going to form what? So I'm just trying to help you understand how this one can be. Now remember that the 3 in the bracket, the Roman numeral number there, it means the valence of iron is 3, and we know that oxygen is 2. So when you react the two, we are going to form iron. The 2 goes this side, and the oxide, the 3 comes to the oxygen. So you have something like this. Okay, so we know sulfuric acid is written as H2SO4. So that is sulfuric acid. And then now we can write our equation now. So remember that the state symbols are not allowed. So what you're going to do is now we're going to say Fe, okay, 2, and then oxygen like this, plus sulfuric acid, and then the forward arrow, and then you're going to have, now remember this is a base but not a soluble base, and this is an acid. So whenever you have an acid reacting with a base, you are going to have water and what? A salt. So you're going to have iron, okay, iron, and we know that the sulfate, okay, the sulfate is a radical. So sometimes when you are talking about the sulfate, for example, this SO4, it has a valence of 2. So meaning the 2 is going to come to the iron, and then in bracket, you are going to have what? You are going to have the sulfate. You have the sulfate, and then now the iron has a valence of what? 3. So it's going to come this side, plus H2O. So plus the H2O, that is water, okay? Okay. Now remember, we need to balance this equation, okay? So for you to balance this equation, you look at iron is 2, and this side it is 2, so that is balanced. Oxygen is 2 plus this 4, that makes it what? 2 plus 4, that is 6, okay? And then hydrogen is 2, okay? But when you look at this on the right side, oxygen is 4 times 3, that is 12 plus 1, 11, okay? So what are we going to do now? So the only thing that you can do is you put a 3 this side, okay? Once you put a 3 this side, meaning the hydrogen will be affected, and every single element in this compound, sulfuric acid. So hydrogen becomes 3 times 2, it is what? It is 6, okay? And then this side it is just 2, so we can put a 3 this side. And this makes it hydrogen balanced, and it is 6 now. Now remember, that this 3 is for this sulfur, and we also know that the sulfur in bracket is also affected by this 3. So sulfur is balanced. And then for oxygen now we have 3 times 4, that is 12 plus 2. Okay, plus 2, that is what? Is going to be, 3 times 4 is 12 plus 2. So this should be 3. Okay, because that is 3. So 3 times 4 is 12 plus 3, 15. Okay, and also this side the oxygen will be 3 times 4, that is 12. Okay, plus the oxygen, which is this one. Now remember, this number in front 3 is also for oxygen. So 12 plus 3, that is 15, balanced. So now we can conclude that this one is what? Balanced. Okay. Again from there now, okay, so this is our A. Okay, now let us move on to B. Okay, now B is saying calculate mass of pure oxide that reacted with the acid. So on this one, the concept is that first of all, we are going to find the number of moles, because we have so much information about sulfuric acid. Okay, so what is going to happen, guys, is we know that when you have concentration, which you can just say concentration is equal to what? The number of moles divided by what? The volume. Okay, so this is the formula for finding what? Concentration. Now we know that our concentration is what? 0.100 moles per decimeter. Okay, so, and then the volume is what? The volume of sulfuric acid is what? 600 centimeter cubic. Now it is very important that you change this volume to decimeter. So we are going to divide both sides by 1,000, and this will give us what? 0.6. Okay, 0.6 decimeter. Okay, so if you want to understand how to change this one, whenever you have the volume in centimeter cubic, you just divide by 1,000 to change it to decimeter. Okay, so from there now we can plug in. Now what are we looking for? So we have the concentration and the volume. What we're going to do is now find the number of moles. So we make number of moles the subject of the formula. So now it is going to be the moles will be equal to concentration times what? The volume. Okay, and then from there now we can say that concentration is 0.100 mole per decimeter cubic multiplied by what? The volume, which is 0.6 decimeter. So from there now, this volume and the units cancels. So this will give us what? 0.0 what? Should be 0. Okay, so this will give us 0.06. So you can check that, guys. Okay, all we are doing is just to multiply. Let's see, so after this decimal we have 4. Okay, 1 2 3 4. 0.123. Okay, so you have to make sure that you understand what you're doing. Okay, we are just trying to find the mass of pure oxide. Now remember that this is an impure. So part of this impure, what reacted was assumed to be what? Pure, because it reacted. Okay. Okay, so this should be this should be 0.06. 0.06 moles. Okay. So make sure you correct that, guys. Okay. So from there now, we can now, what is going to follow is find what? The mass. Okay. Because we are looking at mass of pure oxide. Okay. Okay, so now from this now, the concept rather is going to be that we find, first of all, check out the what is called the mole ratio. Okay, the mole ratio. Now this mole ratio is that when you look at the equation, okay, meaning this iron 3 oxide with sulfuric acid. So you get the numbers that we use to balance it. So you're going to get 3 there, and also there is no number there. So what are you going to get? There is just 1. Okay. So the mole ratio of this iron to the ratio of sulfuric acid. Okay. So now we can see that the reacting moles is 1 to 3. I'm just getting the numbers that we have used to balance, okay? So don't think too much. So from there now, what is going to happen is we are going to say 1 mole of iron reacted with 3 moles of sulfuric acid. Now, what about X moles of this iron, the actual number of moles, okay, produced or reacted with this 0.06, okay? So from there, we can just cross multiply. So this times that will give us 3x, and this times this will give us 0.06. Then from there, I can now divide, okay? Now, once I divide, then this is going to be 0.02 moles of iron 3 oxide, okay? So now, these are the number of moles of what? Of iron. Okay, so this is the part of iron that reacted. Now, after that, guys, what you're going to do now is you now find the mass from this formula, okay? From this formula, you find the mass, okay? So from there now, I'm going to say the number of moles equals to mass over the mixture, okay? Now, this mixture is relative molecular mass of this iron 3 oxide. So how do you find the relative molecular mass? You're going to say that this, we all know this is greater than, so this and this, okay? So we know that this is 3 times what? 16, and this is 2 times, now you have the periodic table, the mass number of iron is what? 56. So this times that, you give us 48, plus this time this, you give us 112. So altogether, this will just give us 160 grams per mole. Now from there, we can now make M the subject by cross multiplication. Now the mass is going to be N times the mixture, okay? So from there, the mass is now, the number of moles is this, 0.02, okay, multiplied by what? 160. So now from there, we are going to get, 3.2 grams okay, of iron, okay. Okay, so now that is the mass of the pure, okay? That was the mass of the pure. So therefore, mass of pure, this ion, equals to what? 3.2 grams. Okay. So make sure that you follow this step by step, and I hope it is clear and well explained. Now let us move on to the last question. Okay. Now what is the last question saying? Percentage percentage purity of iron 3 oxide, assuming that the impurities did not react with the acid. So on this one, guys, what they are saying is that so percentage, okay. Now what is the formula? So that is our so this was B1, okay. And now let's find B2. So in that case, now what you're going to do is we know that percentage purity, okay. Now percentage purity, guys, you can see, is equal to mass of pure, okay, mass of pure divided by mass of, okay. So let me make it clear, guys, so that we understand. I'm just going to use this same one. So percentage purity is equal to what? So percentage purity will be equal to mass of pure divided by mass of impure. Now this multiplied by what? 100%. Now remember, the mass of pure, okay. So the mass of pure is 3.2, okay. So meaning we are going to say 3.2 grams divided by the mass of impure, okay. So when you go back to this, now 4.00, just 4 grams of impure. So the mass of impure for iron 3 oxide was what? 4 grams. So you get that 4 grams, and then you say 4.00 grams multiplied by what? 100%. So from there, what you're going to get is what? So you get 80%. Okay, so that is the answer. So the mass of percentage purity of this iron 3 oxide was almost about 80%. So only 20% of that were the impurities of iron 3 oxide. So thank you so much, guys, for watching. Remember to support, subscribe to my channel, and also like and share this video. It's bye-bye. I'll see you in the next video.